Hi, I would like you to think about the clothes that you're wearing right now. When did you get them? How long have you had them? And when you eventually decide to get rid of them, what do you think will happen to them? The fashion industry produces an alarming 80 to 100 billion new garments annually, with less than 1% of them being recycled, leading to projections of 2,600 garments per person by 2100. The industry emits more greenhouse gases than aviation and maritime combined. On average, a garment is worn only 10 times before disposal, exacerbating environmental impact. Cotton production has nearly dried up entire seas and caused high rates of throat cancer in surrounding regions. The Atacama landfill in Chile, visible from space, has been declared an environmental and social emergency by the UN due to chemical leakage. Mitigating this problem is challenging due to the industry's massive scale and consumption patterns. Recycling different types of fabric is challenging due to the lack of automated sorting and high error rates in fabric tags. The lack of traceability makes it difficult to enforce circular economy regulations. To address this, our paper proposes using low-cost microscope images and convolutional neural networks for fabric identification, alongside UV markers for traceability. We evaluated our solution by creating three datasets, one with 840 microscope images of 14 fabric types, another with UV marked fabric samples annotated for training and validation using YOLO V8, and a third, tracking fabric images through up to 10 wash cycles to assess durability and traceability. Here are my results for fabric sorting and identification from microscope images. Both algorithms did well, with a max accuracy of 90.4%, although there is some confusion in classifying blends. These are my results for the UV marker approach on new fabrics. Both X's and O's are well identified with an MAP of 0.98. These are my results for the wash experiments. The MAP is lower at 0.93, but both X's and O's are still well identified. These are comparisons between the new fabrics and the wash fabrics. This is how my solution compares to others. Other solutions either do not handle both sorting and traceability, are very expensive, or are just hard to scale. Our fabric identification and UV marking approach shows promise, though fabric blends pose challenges. A two-phase classification method could improve accuracy, and our UV markers remain readable after 10 wash cycles. While markers seem safe, further study can be beneficial. Variants like visible ink stamping or coding on tags are also viable. Due to the lack of public datasets, we have made ours available. Future work will be to expand fabric testing and develop an automated prototype. Thank you so much for listening.